Being parked in orbit, a mere stone throw from Earth, the moon was easy. But Mars is a whole different animal, plagued with challenges until now. But that's old news. With the new multi-stage strategy mission, Mars is suddenly a whole lot easier. And even the frightening Martian descent, popularly known as the 7 Minutes of Terror, has a viable solution. Could we put footprints on Mars in 2033? Or is Mars a mountain that we shouldn't climb? Let's find out. Hit the like button if you want to go to Mars, buckle up and continue watching. When Neil Armstrong set foot on the moon, it changed something in every mind. It told us that we didn't go there because we can, but because we cannot be stopped. The lunar footprint sent technology and medicine forging ahead where it may not have. It created advancements, not because we can, but because we cannot be stopped. Since the lunar footprint, we have created the internet and connected the world. We have created solar energy, high-definition televisions, and mobile phones. We have fought pandemics and made artificial limbs and printed organs. We have unraveled our genetic code to redesign and exceed nature's own plan for us. Not because we can, but because we cannot be stopped. Going to Mars isn't something that everyone has to agree with. Let's take a moment to go over the history of the existing preparations and research for a Mars mission, which started about 2 million years ago. At the time, the Earth was populated by various species of humans. It sounds incredible just to say that, but that was the case. The fossil record suggests a complex and branching human history, with multiple hominin species coexisting in the same geographic regions. There is clear fossil evidence that 4 species of human coexisted: Homo rudolfensis, Paranthropus boisei, and Australopithecine. However, there was a 5th primate that appeared suddenly in Tanzania, which was markedly different to the others, and that's because it was our direct ancestor, Homo erectus. Homo erectus was remarkably different at the time because he stood upright and walked. As well as freeing the arms for gathering, carrying, tool-making, killing, and expression, walking also provided the means for local exploration, foraging, and weapons. Homo erectus was a big physical upgrade on the other hominids. Fully standing, they had hands for expression and signals, and the imagination to make tools and explore. They had highly developed emotions and were loyal, caring, and protective. Homo erectus had the ability to reason, plan, trust, and assess. Why is our anthropology so important in the decision over going to Mars? 200,000 years ago, something extraordinary happened again in Tanzania. After 1.9 million years of dominance by Homo erectus, a new human species appeared. It wasn't so physically different, but its brain capacity was a rocket ship. The new human was vastly intellectually superior to Homo erectus. It had less powerful, but more reasoned emotions, ultra-intelligence, and limitless imagination. It could plan meticulously and collaborate as a team. It feared nothing and was the most dangerous animal on the planet. It was 1,000 times more cognitive than the Homo habilis and 100 times smarter than Homo erectus. But the key behavioral difference was that this new human had unquenchable curiosity and drive to find, search, explore, and migrate. Having left Africa about 150,000 years ago, it has in that time migrated and flooded the entire planet, the moon, and pretty soon Mars. That new species of human was, of course, us. Homo sapiens. Now for the question of going to Mars, should we or shouldn't we? Mars' atmosphere is mostly carbon dioxide, with 1% of Earth's atmospheric pressure. This would make for a horrific accidental death. Mars' surface temperatures can drop to 125 degrees Celsius at night. The average daily temperature on Mars is 85 C, and we couldn't even live underground as the first 200 meters of the Mars crust sits at a constant minus 56 degrees Celsius. To provide suitable warmth would require lots of solar panels or a nuclear reactor. Any sudden problem with these electrics would see everyone dead in 2 days. And if it's not temperature to contend with, even the Martian dust is toxic to humans. Landing all this equipment down to Mars' surface is almost impossible owing to the unresisted fall. And as if to spite us, Mars' thin atmosphere is not deep enough to usefully engage and resist a falling craft up higher. Yet it is still hard enough to incinerate a craft when the two do eventually engage. The chosen Maranaut crew would have to be a miracle team of people. The only planetary isolation experience we have is the Apollo mission, and in those cases, the Earth was only a few days away. A mission to Mars would mean far planetary isolation. There is no telling if someone might fall into a steepening panic as they progress more toward Mars, with Earth ever permanently receding behind them. The difference is that with a Mars mission, once the craft is 2 weeks away, comes the deep realization that no one can help them if something goes wrong. And after all the dangers we've covered so far, comes the wonderful threat of radiation. On Earth, we're all protected from radiation by the magnetosphere. That radiation contains all the radiation types that animals cannot be exposed to, including X-rays, gamma radiation, and intense ultraviolet light. In space travel, radiation is a big problem, being negated and managed by a combination of active and passive methods: crew planning, flight planning, and ship rotation. As we know, there is little to be gained financially from any Mars mission. A footprint mission will at least satiate our burning drive to conquer and will relieve us of the need to travel there again. A colony mission is quite simply out of the question. Any thought to establish a colony on Mars is irresponsible not just to our generation, but to future generations. It would be a cost that we would bear and maintain and transfer onward to future generations who may be very opposed and appalled at the colony and at how much of their lives are demised to maintain that cost. Returned in any form of value, that cost would permanently compound and impoverish the planet of rare metals, fuel, human hours, and prosperity. A Mars colony will bring a darkness to planet Earth that we shouldn't have to need, and that our descendants shouldn't have to bear, especially not along with all the nuclear fission waste that is already on their doorstep to permanently maintain for us. Our generation has been incredibly irresponsible with resources, but a Mars colony would be the height of selfishness. While a Mars colony mission is frankly ridiculous, there are, however, 2 sound ideas to consider to make a Mars footprint mission a lot safer and more economical. The first idea is not new to anyone. It is to use humanoid robots, and the technology to do this is quickly manifesting. Human-type robots with arms and walking legs would mimic humans as well as safely test a full mission Mars landing. Unlike humans, robots don't need food, bathrooms, heating, cooling, or radiation shields, dramatically economizing the mission. But most importantly, robots aren't killed by rapid accelerations or decelerations. What this means is that the robot mission could accelerate to a very high speed and decelerate just as quickly, allowing the flight time to only take 50 days or so. Because a colony mission is simply untenable, how do we achieve a human footprint mission? The way to do this affordably and safely has come from a science fiction author, and to his credit, the idea is gaining momentum. It is called the Multi-Stage Strategy Mission, which proposes to build and launch a depot station to send and park in Mars orbit, ahead of the Maranaut crew's arrival. This depot station will hold food, fuel, water, machinery, and mission objectives, as well as the actual light landing craft, all for a short stay in historic walk on Mars. The depot would be built in Earth orbit, loaded up, and then space launched toward Mars. This means that once the depot arrives at Mars, half the mission is accomplished safely and economically. So how could we get most of the mission up to the depot in Earth orbit, cheaper than a traditional ground launch? By employing dual-purpose launches with other launch companies, materials and colony equipment could be launched up to the depot station at considerably less cost per kilogram than if for a dedicated mission. Being space-built and space-launched, the Mars station could be loaded up with considerable payload and fuel, and launched and accelerated slowly toward Mars, taking perhaps 3 or 4 years to get there. So far, this is the whole mission safely sent to and placed into orbit of Mars. Soon after, the Maranaut crew would arrive in their journey craft and dock with the depot station to check and prepare the attached small, highly fueled landing module, which will allow them a slow, safe descent. This multi-staging of the mission is what will make the treacherous descent safe and possible. Descending and landing a heavy craft from Mars orbit is the single biggest hazard and obstacle against us visiting Mars. This is why the weight of a colony mission craft renders the mission impossible, while a footprint mission with a small light craft with plenty of fuel makes Mars easy. Trying to ground launch a full Mars mission defies logic, but to then try and land it on Mars is idiocy. So the only way we will leave a footprint on Mars is using the multi-stage strategy. Incredibly, the 7 minutes of terror could become the 21 minutes of boredom. So, do we go to Mars or not? If we do a colony mission, it will not think about consequences or effects of tomorrow's generation. It will not consider the state of the world, the economic crisis that ensues, an economic depression that may freeze the endeavor mid-mission, or the possibility of war. So, will we go to Mars or not? If we go, it would be a footprint mission using the multi-stage strategy. The question arises, how would a footprint mission work both financially and politically? While a handful of nations should be able to carry a footprint mission, space exploration should instead be forming into a national collaboration, with members able to share facilities, launches, and space hardware and assistance. A Mars footprint mission, while also serious if shared between a group of nations, would easily be viable and doable. And let's be clear about a footprint mission. It is a go and return mission with no staying, which means that the journey there and the departure back need to occur within the same opposition to Mars. In astronomy lingo, the term opposition refers to the time when Earth and Mars are the closest to each other during their differing orbits. The opposition occurs every 26 months, and of course only happens when both planets are both on the same side of the Sun. However, the Earth-Mars opposition sways outward and then inward over 16 years, which means that Mars creeps far away at oppositions times for 8 years, and then returns back closer for the next 8 years of oppositions. So over 16 years, we will have a far opposition and a close opposition. These distances are quite significant, and the time to send a footprint mission would be far more difficult during a furthest opposition. At a typical close opposition, Mars is around 50 million kilometers away, while at a furthest opposition, Mars is around 400 million kilometers away. This disparity is yet another major difficulty in pursuing a colony mission. Why? Because in order to have a critical supply flight to Mars every 26 months, including the need to return crew who have gone crazy and to replace them with fresh crew, 1/4 of our journeys to Mars will need to make a very early start, taking up to 10 months to get there and 10 months to return. So within the pretext of a colony mission, several of the crew and depot missions would be traveling 4 times the distance and twice the time to travel between Earth and Mars, exposing the crew to dangerously long periods of stray radiation. Could we skip crew and transfers and only send depot supplies? Yes, but that would demoralize the colony crews and deprive them of medical aid, psychiatric aid, and of the option of return for 4 or 6 years. Also, if there is equipment failure or a need for a small amenity, it would all have to wait. That's a big stretch. So, as we can see, a Mars colony mission is really just science fantasy. It can never realistically happen, and anyone thinking it can clearly hasn't considered everything. As for a footprint mission, yes, it could absolutely work if scheduled for a closest opposition, such as the 2033 or 2035 or 2037 oppositions. Ideally, if the sending journey could get there, land, and get the Mars walk done and dusted before the opposition, then the returning journey would be toward an Earth that is still traveling toward it. What advantage would be gained by doing this? To choose to get to Mars early, which means expending more travel fuel, also increases the critical safety window for the return, which is much more favorable. The earlier the craft leaves for return, the less catching up it has to do as the point of opposition passes, and this would play well for the crew who have already been in space for months, walked on Mars, and are looking forward to returning to Earth with minimum delay. By employing space-only launches, pre-delivery of mission hardware and fuel into Mars orbit, and using a light landing module for the actual walk, a Mars footprint mission is not only possible, but totally doable now. In fact, if we were to begin the process of assembling a Mars depot in Earth orbit, stocked it with fuel, the lander, and supplies, and had it launched in 2029, and then allowing 4 years for it to reach Mars, we would effectively have half the Mars mission accomplished. So, should we go to Mars? We wanted to say no, and we tried to say no. We know that a Mars mission is irresponsible in a world where so much poverty exists. We know that political turmoil and clashing ideologies and opposing nations all make it the wrong time to send a Mars footprint mission. So there are 2 words to grapple with: no and no. While the pragmatic decision to go to Mars is no, the human decision is based on what we know. And what we know is that there will never be an ideal time. The correct decision is to say no to a Mars mission. There is no justification and nothing to be gained economically. And yet, we all know somewhere deep down that watching that Maranaut take that first step on another planet will somehow lift us all, raise us, give pride to us, and joy. But mostly we will all feel a sense of unified pride in who we are, the people species. The final verdict? We all may as well buckle up and enjoy the ride, because we're going to anyway. You want to know why we're going to do it anyway? Not because we can, but because we cannot be stopped.